Okay, I'm just going to work through exercise 6E really quickly. So, finding the surface area of a cone. They've given us the diameter, so make sure you get the radius. Adding the slant height. At that point I would just evaluate. Two decimal places. 89 goes to 90 kilometers squared. Question 5C, finding the surface area of a pyramid which is inconveniently upside down. We do have the slant height of the pyramid, of the triangle. Base is 0.2. Slant height is 0.3. At that point you can just evaluate. Whoops, see what happens with the calculator there. 0.2 squared, let's just do it the easy way, plus 2 times 0.2 is 0.4, times 0.3, 0.16. We're in meters squared. 6C, they want me to find the curved surface of the cone only, and they've given me the diameter again. So the curved surface we need to go back to pi r s. Terrible habit of writing that as a power. And it's pi times radius is 26 divided by 2, which is 13. Slant height is 48. Now, did they want an exact answer? They want 2 decimal places. And we're in millimeters squared. Now, they didn't give me a diagram, but they've described a cone, so it would be most appropriate to draw a diagram. It's got radius 3 centimeters and height 10 centimeters, and if we're not sure if they mean the perpendicular height or the slant height, we read the question, and it says use Pythagoras' theorem to find the slant height. So the slant height is indeed what I need. So question A. Pythagoras, c squared equals a squared plus b squared. The slant height squared is 10 squared plus 3 squared. So the slant height squared is 109. Slant height is the square root of 109. Now okay, they've said to round my answer to 2 decimal places, which I suppose we'll do. But as you know, we are not fond of rounding. The calculator didn't want to do it either, 10.44. We're in centimeters. Now that's the slant height, so that's just in centimeters. Now if I was going to then use that for calculations, I would just use that value, because they would then like me to find the total surface area of the cone, right, to 2 decimal places. Let's use the other formula for once, pi r squared plus pi rs. Now, since s is the square root of 109, I'd just use that. It's easier than writing 10.44 anyway, and it's more accurate. And at that point you can evaluate pi times 3 squared is 9, plus pi times 3 times the square root of 109, 126.67 centimeters squared. Question 8, they're getting us to do some problem solving, and again they haven't given me a diagram, so I draw one. A cone with radius 5 centimeters has a curved surface area of 400 centimeters squared. I need to find the slant height and then find the height. So I have a formula for the curved surface area. They are being tricky, aren't they? That would be pi rs, and that's our surface area. So I substitute in what I know. I know that's 400. Sorry about going a little wonky there. Which would be pi times the radius times the slant height. It's a 5 and an s. So we're dividing by 5 pi on both sides. 400 divided by 5 pi is my slant height. Which is 80 pi, obviously. Sorry about that. And they would like that to 1 decimal place. Sorry, my equal signs really should be aligned here. I'm being very lazy. 251.3 centimeters. That's the slant height, so that's just units of length. Really, I shouldn't be leaving these spaces. I should be keeping my equal signs aligned, so I'm getting a bit messy here. Once you've got the slant height, of course, we can find the perpendicular height, which was question 8b. We are finding the shorter side of a triangle, so that's a squared equals c squared minus b squared. Height squared is, so the slant height, 251.3 squared, or could have used, of course, use 80 pi squared, minus the radius is 5 squared there. H is going to be the square root of all that. So I'd probably just enter that all in one, remembering to put brackets around this whole expression here, which, oh, actually, yours would probably be okay without it, but it's good practice to put brackets. I'm sure this is just a squared button. There it is. That's 5 squared is 25. Close your brackets. 251.25. We want 1 decimal place. So that's 3 centimeters squared. Question 9. Again, no diagram. Draw a diagram. A cone, again, with radius 6.4 centimeters, has a curved surface area of 380 centimeters squared. This is the slant height and the height again, so I'm not going to bother doing that because I just did one. Question 10. Now we have a pyramid. They drew me a diagram. It was very nice of them. They've given me the base and the height. I need to, but they've given me the vertical height of 6 meters. So of course what I have is 6 meters. Now if the base of that square pyramid is 4 meters, then I will only need 2 meters along here. So just in case you're uncertain, Here's question 10. You'll see it's 6 meters vertical height. We're going to need to find the slant height to be able to find the area of our triangle. We have 4 meters across the whole shape, but to get that right angled triangle in the center there, because this is perpendicular height, we'll only need half of that, so that's 2 meters. And that's nice and easy. We're just using Pythagoras for 10a. Let's try to get my working a little neater this time. So c squared is 40, c is the square root of 40. Again, if I was being accurate, I would leave your height at square root of 40 rather than doing what they've asked you to and evaluate to 1 decimal place, because that keeps it as a more accurate answer. Now, they've asked me to evaluate that. I'd absolutely be using this, the square root of 40, in this next question, question B. Oops, don't forget your units. Where I'm going to need to find the total surface area. This is a much more accurate answer to use. Surface area of a square pyramid. Now the base, remember, is not 2 here, it's 4. And the slant height is root 40. So that's 16 plus 8 root 40. .596. This wants 1 decimal place, 66.6 centimeters squared. You might be interested in calculating this with 6.3 instead of the square root of 40 and checking how much of an error you get. Sometimes there won't be an error, but it might be interesting to have a look. Question 11 is comparing two party hats A and B. They haven't given me a diagram, so I'll draw one. Open cones with no base. 7 centimeter radius. And this is sort of one for a kid with a bigger head, perhaps. And they would like me to compare the surface area of these party hats. Surface area of hat A. Now, this is the slanted face only, pi rs. That's 25 times 7 times pi. They didn't tell me, so I'll go to 2 decimal places. Surface area. Surface area of B. We write our formula. Substitute our values. Sorry. 622.04 centimeters squared. Therefore, B is larger. Or from the question, which hat has the greatest surface area? Technically, I really should compare these, so subtracting B minus A is if we were being absolutely perfect with our working, I still got the answer to that previous one there, which is quite useful. Equals 72.26 centimeters squared. But really what we need is B is has greater surface area. If we wanted, we'd say by 72.26 centimeters. Question 12 is composite surface area. That's been long enough. I'll leave you guys there.